So today we're going to look or begin looking at system of equations using matrices. Now, before we get going, just know that your calculator has some methods where it knows how to solve using matrices, but you are going to need to be able to show the steps yourself. So I'm not even going to give you instruction on the calculator, but if you already know how to use it, it's a great tool for this topic, but I'm not going to spend a whole lot of time with it. But just know that you're going to need to show your work. All right, so we kind of talked about this last time, but a matrix is just a collection of numbers in rows and columns. The purpose of a matrix is to basically perform calculations on a set of numbers quickly and efficiently, usually all at the same time, kind of like we compared it to Excel. So I know we talked about this last time, but this is a 2x2 matrix. We will go up to a 3x3 matrix, or a version of it at least. But just know that some of your higher level business classes may go higher than that. But at that point, you would be using the calculator, even possibly a computer system to help you with that. So these are just regular old vanilla matrices. But what we're going to probably be spending most of our time on is augmented matrices. Remember, matrices is just the plural form of matrix. Okay. So an augmented matrix is specifically used to represent a system of equations. And remember, a system of equations from last time is just a set of equations using the same variables that work together. But essentially what it looks like is it's just a matrix with an additional column, and that additional column represents the right side of the equal sign. So here is an example of a 2x2 augmented matrix. So you have maybe a set of numbers like we had before. By the way, we always use brackets to mean that the numbers inside are a matrix. Okay, so you will always see those brackets surrounding the numbers. But an augmented matrix will have a bar that actually represents the equal sign. Okay, and then another column of numbers. And so these numbers have meaning. These are the x coefficients. These are the y coefficients. And then the bar literally means an equal sign. So this first row stands for 2x plus y equals 7. The second row stands for 5x plus 6y equals 8. And so basically we're going to learn how to quickly perform calculations on just the numbers. So notice what it does. It pulls the coefficients or the numbers out and it leaves the variables out of it. Okay, so it's just going to be kind of like Excel is. We're going to perform just number operations. All right, so the biggest that will go is 3 variables. So let's look at what that looks like. So you always, in an augmented matrix, have this bar here to represent the equal sign. So notice we have more numbers though, right? So this first column would still represent the x numbers, the x coefficients. This would be the y coefficients, and then we add a third variable, okay, usually z. But then the bar is still the equal sign. So this first row would look like x plus 2y plus 3z equals 5. Notice I make my z's look like a slash through them so they don't look like 2's. So if your 2's and your z's tend to look similar, you need to have some way to tell them apart. So that's why I use that. What about the second row? How would you read the second row if we're going x, y, z, and then an equal sign? 4x minus 2y plus 3z equals what? 1. And then same thing with the last one. So it just goes in x, y, z order. Okay, so notice when we're using 3 variables, we have one more equation, right? So it's kind of like, in general, we won't always have it, but we would like to have as many equations as we do variables. Okay? So later on, probably this week, we're going to look at some that may not always come out like that, but that's what we would prefer. Okay, so our goal is to reduce any matrix that we get. So let me show you what reduced matrices look like specifically. So here's an example of a 2-variable reduced matrix. Okay, and what makes it reduced is not the right-hand column, it's the stuff on the left. Okay, so let's talk about why this would be considered a reduced matrix. Okay, the fact that there are zeros specifically placed is kind of important. So notice if you tried to tell me what the first row would read as, what would the first row read as? We don't even have a y, right? So it would just be what? X equals 2. And what would the second row read as? Y equals 3. Okay, so note that the solutions will vary. But if we can get our matrix to look like this, then we have what x and y are, which is, remember, what we're trying to find when we solve a system of equations, right? We're trying to find what is the x and what is the y. Okay, so let's look at the 3-variable version, and then maybe we'll notice a pattern. Okay, so on the left is the reduced format. On the right is just whatever the individual answers happen to be. So that's why I'm writing solutions will vary, because the numbers on the left or on the right rather, will be different. Okay, so why would it be helpful for a 3-variable matrix to look like that? Same reason as the first one. What's the first row going to read as? X equals -4. Y equals 2, and what? Z equals 5, right? Okay, so in other words, here the solution is the point 2, 3. And here the solution is, I know we haven't done 3 variables, but when you have 3 variables, you write it with the parentheses around them, and you just have 3 numbers. And you go in X, Y, Z order. Okay, so like I said, we won't do any that are bigger than that, but what do you notice about the ones? Bless you. What do you notice about the ones in both patterns? They're kind of like in a diagonal, right? And then what fills all the other spots? Zeros, okay? So if we had a 4x4, which we won't again, but you might in other classes, you would have the ones in a diagonal just like this, and you'd have zeros everywhere else. Okay, so even if it gets bigger, the pattern is pretty much the same concept. All right, so let's go ahead and kind of write down the gist of that. So the pattern that we want, so the pattern for a reduced matrix is ones in a diagonal and then zeros everywhere else. So just so you know, our goal is going to be to get our matrices to look like this. They're definitely not going to start off with this pattern, but we're going to want them in the end to look as close to this pattern as possible, because if they do, we'll be able to tell what X, Y, and if there is a Z, we'll be able to tell what that is too. So our goal, our end game is going to be for our matrices to be transformed or changed into reduced versions like the one I have listed above. Okay, so we are going to be able to do these with a combination of operations. Okay, now we're going to talk about why, but we are only allowed to do operations to the row, never to the column. Okay, just to make sure we're clear on what a row is. Is a row horizontal or is a row vertical? A row is horizontal, right? Columns are vertical. Okay, so make sure you know that. So one thing that we can do is we can swap any two rows. Okay, so I'm going to give you an example of this, but the notation that you use to say, hey, I want to do a row swap, will look something like this. Okay, I'm going to use a parentheses here. So you will say R1 and then possibly something like R2. Let me move that up, sorry. Notice it has a double-sided arrow, so like what picture-wise does it look like you're trying to do with the two? Swap them, right? And so this literally means to swap rows 1 and 2. Okay, so let's look at an example of that. So let's say that you had the following matrix. 2, 5, 3, and 1, 4, 2. Okay, remember our goal is to get the pattern of 1 in the diagonal and zeros everywhere else. Okay, so what I could do here is I could say, okay, I'd really like to swap rows 1 and 2. Why would I like to swap rows 1 and 2? What would it get in the right location if I swapped rows 1 and 2? The 1, right? So if I swap rows 1 and 2, I don't change anything other than just the location of the row. Okay, so this would be the new matrix once I swapped rows 1 and 2. Okay. Remember, though, that these are just equations, right? So this is just 2x plus 5y equals 3. And this is x plus 4 equals 2, 4y. And when you swap it, I didn't change anything, right? I didn't change any values. What's the only thing that I really did? Yeah, so in other words, like, aren't those the same system? All I did was write the other equation first. Okay, so that is why you're allowed to do a row swap. Okay. Okay, so that's the first operation. The second operation is you are allowed to multiply an entire row by any constant you want. Okay, so we're going to talk about notation of how to write that, and then we're going to talk about why that's allowed. So I think a lot of this notation is kind of intuitive. Okay, in other words, like the double-sided arrow looks like you need to swap those, right? You need to switch them out. And so if you had something like this, what do you guess I'm asking you to do with row 2? Multiply it by 2, and that's exactly what it means. Okay, so 2 row 2 means to multiply all of row 2 by 2. So let's look at a quick example there. So let's say that you had maybe the following in a matrix. You can have fractions. So maybe this is our collection of numbers. But let's say I want you to do 2 times R1. Okay. Usually you write an arrow to imply that, hey, we're going to write a new matrix with this change being made. Okay, so 2R1 means I want you to do what? Multiply row 1 by 2, right? But notice, since I didn't mention row 2, what do you think happens to it? Stays the same, yes. So I'm going to pull over what doesn't change, because notice I didn't mention row 2 in this one. But then row 1, if you multiply a half by 2, you get 1. Multiply 2 by 2, you get what? 4. Multiply 1 by 2, and you get 2. Okay. So let's talk about why we're allowed to do that. Okay. So remember, this means 1/2 x plus 2y equals 1, right? This is 3x plus 4y equals 5. Okay. So notice what I did to get over here, right? I just multiplied everything by what? Multiplied everything by 2. And remember, in algebra, you're allowed to multiply one side by any number you want as long as you also do what? Multiply the other side by that same number, right? So if you were to multiply by 2, then you get what we got over here. So it's just a way to kind of, again, pull out the numbers and do calculations with them, and then you plug the variables back in. Because I don't think it's any mystery that, a lot of us are intimidated when we have a whole bunch of variables, right? We don't like to have a whole bunch of letters. And so a matrix removes those letters, lets you do math to the numbers, and then you put the letters back in. Okay? Okay, so the third and final thing that we can do to a row, because there's actually only 3 row operations we can do. We can swap a row, we can multiply an entire row by a single constant. I'm going to put a star by this one. This is probably going to be one of our most often row operations, but it's also the most challenging to try to explain. So I'm going to show you an example in a minute. So the third thing that we can do is we can replace any row by adding a multiple of another row to it. Okay, so this is the gist of what we're going to be doing. Okay, we're going to add another row to the row we're trying to replace. So different textbooks show this rule differently. So I'm going to show you the notation for this textbook, but if you had another class where you learned about matrices, and it's okay if you didn't, but I'm saying if you did, you might notice that it might be a little bit different. For instance, like the college algebra book we use here uses a different notation than the business algebra. So I'm going to show you how our book shows it. So if you see this instructions, so R1 plus 2R2, and then an arrow to R2. Okay, so what this means is they want you to replace row 2 by adding row 1 to 2 times row 2. Okay, note that the arrow points to the row that changes. So the way some people remember it is it's like we're sending R1 plus 2R2, we're sending that to row 2. Okay, so we're going to edit and replace row 2 with that calculation. So I think you can see why this one is a little more challenging. So let's do a basic one, and then we're going to practice a few more of these. So let's say this is the matrix that you have. 1, 3, 5, and then -2, 4, 6. And so let's say this is the instructions I give you. I'm going to literally do the same one I did up there. Row 1 plus 2 row 2, and we're going to send that to row 2. Okay, so remember the arrow points to what in general? The row that's changing, right? So what row is not changing then, since the arrow is not pointing to it? Row 1 is not changing. So we would write that again. And then you just need to be able to add and multiply in your head. You can use a calculator if you want, but I think it's just going to slow you down. So we're just going to take it kind of slow. So you just need to perform this operation for each set of numbers. So you're going to take row 1, okay? And actually that's not what I wanted, so let's change that. I want it to actually be helpful to us, and what I have there is not going to be helpful. So we're going to take, let's switch them. Just switch these two if you have an eraser. So I actually want to do row 2 plus 2 row 1, but I still want to send it to row 2. So I just want you to swap that instruction there. Okay, so we're going to follow the instructions. So here's row 2, what I'm pointing at here. Okay, these are kind of visual exercises, so you'll want to try to do it as we go with me. So it's row 2 plus twice row 1, right? So what is twice row 1? 2, right? And we want negative 2 plus that 2, which would be what? 0. Okay, and then we're going to do it again for these pair of numbers, right? So we're going to take row 2, which is what? 4, and we're going to add what to it? 3 times 2, which is 6, right? So what is 4 plus 6? 10. And then last but not least, we take row 2, right? And we add twice row 1 to it, right? So row 2 is what? 6, and we're going to add double 5, which will be what? 16, right? 6 plus 10 will be 16. Okay. So it's just going to take some time. It can be a little tedious of a process. So let's practice. Let's practice with maybe some 3 variable systems. So I want you to perform the indicated row operation. So let's say this is the matrix I have. 3, 1, 2, and then the bar 0. I'm not going to read the numbers off. I'll let you just copy them. So you'll always be given a matrix to start off with. Bless you. And then you'll be asked to change it in some way. Okay? So let's say that the change I asked you to make was this right here. Now the arrow just implies that, hey, we want you to make the change. Okay? Okay, so in words, what am I asking you to do then? Multiply row 3 by a half, right? Or take a half of row 3, right? So which rows am I not telling you to change then? The first 2, right? So a lot of these matrix operations is just realizing that some of the stuff is just going to get copied over. I always like to copy over what's not changing first, and then I worry about what's changing. Okay? So I just need to do what with everything in row 3? Take what of it? Half of it, right? So half of 2 would be what? 1, half of 4 would be 2, half of 6 would be 3, and then finally half of 10 would be 5. Okay? Probably one of the bigger mistakes is to forget to do the operation to everything. So make sure you do everything, the whole row, even what's on the right side of the bar. Okay? Okay, so let's spend some time. I really think that the third row operation is the most difficult. Okay, so I'm going to say same instructions. In other words, perform the following row operation. So let's say this were my original matrix. Sorry, let's move it up. Here we go. So far I haven't told you what we're going to do, but let's say this is the instructions I give you. So -2 row 1 plus row 3, and we're going to send that to row 3. Okay, so which row is being changed then? Row 3 is changing. So wherever the arrow is pointing, that tells you what is changing. So by default, what does that mean about rows 1 and 2? They're staying the same. So I'm just going to pull them over. Notice you can get like 2/3 of your numbers, right, just by pulling over the information that's not even changing, right, just by copying down what you know isn't changing. But then we're going to pause here and make sure we do this right. So let's read what we're doing. What are we doing to rows 1 and 3? We're multiplying row 2 by what? Or sorry, row 1 by what? -2, right? And we're adding that to row 3, right? And we're putting it in the row 3 spot, right? So if you want to, if you like to kind of visualize, we're really just messing with these first and last rows, right? So we're going to do -2 times this plus this, right? So what's -2 times 1 plus 2? 0. Okay, and then let's do it again. Move your fingers over here, right? Now we're going to do -2 times this number plus this number, right? But what's -2 times 0? What's anything times 0? 0, but then when I add it to the 3, it stays what? 3. So now I move on to these duo pair of numbers, right? So -2 times 2 would be what? -4 plus -6 would be a -10. And then lastly for this one, -2 times 4 plus 4. So -2 times 4 is what? -8, and then plus 4 would be -4. Okay. So I'm not saying you can't use your calculator. I'm just saying that I think it's a little tedious to have to punch them all in. It's actually just a collection of multiplying and adding. So I feel like if you go slow enough, you can do that without a calculator. But if you feel like you need it, go ahead and get it out. And I don't know why I called this example 4. So this would be example 2, right? Okay, so let's look at another one with 3 variables. This is going to be actually how you're going to see 3 variable row operations most frequently. So to save time and, frankly, paper, sometimes you will get a couple instructions in one step. So let's say that is your original. But this time I'm going to give you 2 steps. So the first one looks like this. And notice I didn't use a parentheses. You'll see it sometimes, and then sometimes you won't see it. So I'm going to probably not use a parentheses, but it's fine either way. So what I want to be clear about is these are separate instructions. Okay, you will not do them together. They are completely separate changes that need to be made. Okay. So which row is changing in the first statement? Row 2, right? And which row is changing in the second statement? Bless you. Row 3? Okay, so which row is not changing because it wasn't mentioned at all? Row 1 is not changing, so let's move that over first. And then just know that these changes don't have anything to do with each other. Okay, so you can do them in any order because they're not going to use each other in order to do it. So I like to tackle the easiest one first, okay, because this looks pretty easy, right? What am I asking you to do with row 1 and row 3? Add them up, right? No multiples or anything, right? So I think we can do that pretty easily. So what's -1 plus 1? 0. What's 2 plus 4? 6, right? Notice I move my fingers. If you're like a more visual learner, then it's maybe helpful to kind of point out what you're doing. Okay, you don't have to, but that's the way that I learn the best, so that's why I do it that way. -3 plus 5 would be what? 2. And then 4 plus 8 would be 12. So that's my new row 3 after I've done that change. So last but not least, let's do this one. Okay, and again, I only did it out of order just because I thought the second instruction looked easier to me. So what's the second, or the first really, instruction telling you to do? Double what? Double row 1 and add it to what? Row 2. Okay, so we're doubling row 1 and we're adding it to row 2. So let's point them out. So twice 1, 2 times 1 plus -2 is 0. Okay, now move on to the next pair. 2 times the 2 plus 3, so 2 times 2 is 4, plus 3 is 7. And then 2 times -3 plus 4, so 2 times -3 is what? -6, plus 4 is -2. And then last but not least, these two, right? 2 times 4 plus 6, so 2 times 4 is 8, plus 6 is 14, okay? If you're not trying to actively do this with me, then you're probably kind of wasting time in being here today, to be honest. If all you're doing is copying down numbers, they're not going to mean anything to you later. So you need to try to see if you can do the multiplications and the additions with me as you go, okay? So this is not a great day to just get a copy of the notes and, write a whole bunch of numbers down, because I don't think it's going to mean a whole lot. Okay, by the way, notice that this one might not look reduced, but it looks closer to the reduced version than I started off with, right? Because what do I really want in the end? I want ones in a column or in a diagonal, right? And I want what everywhere else? 0. So it was a step in the right direction, right? It doesn't look like it should quite yet, but it looks closer to my reduced version than it did before, okay? So that's going to kind of be our goal. So let's write out some steps. We're going to start with 2 variable systems where you have to decide what needs to be changed. And I promise if you will do it in this order, it will work every time as long as it's solvable. Okay? So in other words, I want you to do it in some sort of organized fashion. So we're going to start with column 1. Notice I didn't say row 1, I said column 1, okay? So what do I want column 1 to look like if it's a 2 variable? So you might need to visualize it. What do you want the very first vertical column to look like? 1 followed by a 0, right? So keep in mind, you always want to keep in mind, what your goal is. Your goal is to make the first column look like that, okay? So you are always going to try to get the 1 in place first. So here are the 2 ways you can get the 1 in place. Usually by either doing a row swap. In other words, if there's a 1 in the second spot, you can swap it and put it in the first spot like you want it, okay? Or by multiplying the first row by its reciprocal. Okay, so just to remind ourselves, what's the reciprocal? Yeah, so what do you do in general? You just do what with the fraction? Flip it, right? So the reciprocal, I'm going to say the reciprocal of the first number. In other words, if you have a 2 and you really want it to be a 1, you can multiply that 2 by what? And it'll change to a 1. 1/2, right? What if it's a 3 and you want it to be a 1? You could multiply that 3 by a what? 1/3, right? What if it's a 1/2 and you want it to be a 1? You can multiply the 1/2 times flip the 1/2, right? Multiply it times 2. So anything times its reciprocal is always 1, and we're going to use that to our advantage. So once you have the 1 in place, okay, then you're going to work on getting the 0 where you want it. And remember, we have to use our row operations. We only have 3 of them. So what you're going to do is you're going to add a multiple of another row to make that happen. So you're always going to be using the opposite sign. So we'll do some examples and it'll make more sense when we look at an example. But if you wanted to add something to a 3, for instance, that would make it a 0, what could you add to a 3 that would make it a 0? A negative 3, right? What if you had a negative 5 and you wanted that to be a 0? What could you add to negative 5 that would definitely make it a 0? Positive 5, right? So we're always going to kind of use the opposite sign there. Okay, so notice if you complete step 1, then the first column looks correct. So the second step is you're going to repeat steps A and B for column 2, but just remember what you want column 2 to look like is different, right? What do you want column 2 to look like? 0, 1, right? Because think about how it looks, right? The 1s are in a diagonal, so column 2 looks like 0, 1, okay? And then step number 3 is not really a step, it's just an observation. Once you've fixed both columns, you will have exactly what you want. You will have the pattern 1, 0, 0, 1, and you'll have some answer A and B, and that will be your solution. Okay, so we're just going to slowly and purposefully get what we want to happen. Okay, we're going to fix the first column by making it look like 1, 0, and then we're going to fix the second column by making it look like 0, 1, and then we've got it. Okay, did you have a question? Yeah, so we'll get to that, but yes, we will use this exact same process when we get to 3. We'll just do one more step and we'll make it look like we want it to. So when we get to 3 variable, we'll do 1, 0, 0, get that set. Then we'll do 0, 1, 0, get the second column set. And then we'll do 0, 0, 1 and get the third column set. But yes, the same process is going to be used for 3 variables. But we're going to start off with 2 because I think it's less intimidating. All right, so we may or may not be able to finish this one, but I want to start on one. So let's say that I want you to solve this system, and I want you to use the matrix method. So remember, last time we looked at a couple other methods, right? We looked at the addition/elimination method. We looked at the substitution method. Okay, so the first thing we need to do is change these numbers into a matrix to begin with, right? So what will the matrix look like on the left? You just pull the numbers from the equations, right? So what will the first row look like? 1, negative 1, and then don't forget your bar, and then a 7, right? And then what will the last row look like? 1, 1, 1, 1. Okay. Okay, so we're going to start with column 1. What do we want column 1 to look like? 1, 0, right? Notice we actually get something for free. What do you notice is already good to go? Yeah, this is already good to go. Okay, so if it weren't, though, we would try to make it a 1. Okay, but since it's already a 1, we're going to move on to this guy right here. Okay, and what do we want this guy to be? We want this to be a 0. Okay, so we get this to be a 0 by changing which row? Which row do we want to change for sure? The second row, right? The first row is actually good. We want to keep the first row. We want to change the second row. So I'm going to skip a little space. I know that I want to point my arrow to row 2 because row 2 is the row that I'd like to change. So what would be a real easy way for me to combine these rows and get a 0 there? Couldn't I just do row 1 minus row 2? Okay, I don't need to add them because if I add them, I'm going to get a 2 there. What do I want to get there? A 0, right? So notice I'm not changing row 1, right, because the arrow's not pointing to row 1. And then this is a relatively easy one to do, right? 1 minus 1 is 0. Be careful about your signs. Negative 1 minus 1 would be negative 2. And then 7 minus 1 would be 6. Okay? So notice column 1 is good, right? Column 1 is exactly what I want it to be. Okay, so now I'll move on to what? Column 2, right? And you always fix the 1 before you fix the 0, wherever it's located. Okay, so which number do I need to work on next then? You really want this to be a what? You want this to be a 1. Okay, so don't overthink it, but how could I make that a 1? I can just multiply by the reciprocal of that, right? So what's the reciprocal of negative 2? 1 over -2, right? So in other words, I need to do -1/2 times which row? Which row am I looking to change? Row 2, right? So once again, what do you notice about row 1? It's staying the same. Okay, so a nicer way to think of it is we're really just dividing row 2 by -2, right? So what's 0 times anything, even a fraction? Still 0, right? -2 times -1/2 is 1, just like we wanted, right? What about 6 times -1/2? -3, okay? By the way, we are halfway done, more than halfway done really, but you actually know what y is right now. What's y actually equal to? -3, right? So we just have one more number that is not quite what it should be. What's the number we need to work on finally last? We really want this to be a what? A 0? Okay, so let's talk about what we would do. So I'm going to come down here. So first thing, skip a little space. What am I wanting to change this time? Row 1, so I'm going to write my arrow pointing to row 1. Okay, and it's a pretty simple change. How could I make this a 0 combining these two steps in some way? Yeah, couldn't I just add them together? And notice it really doesn't matter which one I list first. So I'm going to say row 2 plus row 1. So by the way, row 2 is not changing this time, right? And we wouldn't want to change row 2 because we already have the answer for row 2. Like row 2 is already what we want. So notice we're going to add them, right? 1 plus 0 is what? 1. -1 plus 1 is 0. And then finally 7 plus -3 is 4. Okay, so then what's our solution? Now that we made the matrix look reduced, now we can tell that the solution is what? 4 comma -3, okay? Okay, notice if we wanted to, couldn't we plug that in and check to see if it works here, okay? So I know that you might not be as comfortable with this method as, say, the methods that we talked about last class, because the methods of addition and elimination, or addition/elimination and substitution is more what we talk about in high school math. And this is probably skipped over quite a bit in high school math, okay? But just know that we're sticking with it for a reason, okay? So you're going to need to make sure you can kind of follow that process. So Friday we'll pick right back up where we left off today.